Language is humanity's most powerful tool. It carries our ideas, our emotions, and our knowledge. And today, machines are learning to understand it. From spell correction to machine translation, from chatbots to large language models, natural language processing is transforming how humans and machines interact. In this guide, we'll dive into 200 unique NLP interview questions and answers, each explained clearly in an interview-style format. Together, we'll cover the fundamentals of NLP, tokens, embeddings, and engrams. Classical approaches like HMMS, CRFs, and LDA. Deep learning breakthroughs, RNNs, LSTMs, transformers, and BERT. Real-world applications from sentiment analysis to conversational AI. Evaluation methods like BLEU, ROUGE, and perplexity. Deployment and scaling with pruning, quantization, and edge AI. The ethical challenges of bias, fairness, and hallucinations. And the future of NLP, multimodal AI, instruction tuning, and AGI. Whether you're preparing for a role at Google, Microsoft, OpenAI, Meta, or any AI-driven startup, this is your complete blueprint to ace NLP interviews. Let's get started. What is NLP and why is it important? Natural language processing, or NLP, is a field of AI that enables machines to understand, interpret, and generate human language. It bridges the gap between unstructured text or speech and structured data that computers can process. NLP is important because language is the most natural medium of human communication. Applications like chatbots, translation, search engines, and voice assistants rely on NLP. Its significance is growing as businesses aim to make machines more interactive and accessible to non-technical users. Difference between NLP, NLU, and NLG. NLP is the broad field dealing with text and language processing. Within it, NLU, natural language understanding, focuses on extracting meaning from text, like intent detection and semantic parsing. NLG, natural language generation, does the reverse, producing human-like text or speech from data, as in chatbots or summarizers. So NLU is about understanding, NLG about producing, and NLP is the umbrella term that covers both. Explain tokens, types, and lemmas. Tokens are the smallest units of text after splitting, like words or subwords. Types refer to the unique tokens in a text. For example, in cat, dog, there are 3 tokens but 2 types. Lemmas are the base or dictionary form of words, like running, run. Tokenization, type counting, and lemmatization are essential pre-processing steps in NLP. What is stemming versus lemmatization? Stemming crudely chops off word endings to reduce them to a root form. So running, runs, and runner may all map to run or even run. It's fast but less accurate. Lemmatization, on the other hand, uses linguistic knowledge to map words to their valid dictionary form. For example, better becomes good. Lemmatization is more precise but computationally heavier. What is stop word removal? Stop words are common words like the, and, or is, that usually don't add meaning to tasks like classification or search. Removing them reduces noise and computation. However, in some contexts like sentiment analysis, even small words like not may be important, so stop word removal should be applied carefully. Explain bag of words. Bag of words, BOW, is a simple text representation where a document is represented as a vector of word counts, ignoring grammar and order. For example, I love NLP and NLP I love would have the same vector. While BOW is easy and effective for basic tasks like spam detection, it doesn't capture word order or meaning. What is TF-IDF? TF-IDF stands for term frequency - inverse document frequency. It weighs words based on how important they are to a document relative to a corpus. Common words like the get low scores, while rarer, informative words get higher ones. TF-IDF improves over raw counts in tasks like search engines and keyword extraction by emphasizing meaningful terms. What are engrams in NLP? An engram is a sequence of n tokens. For example, I love NLP has bigrams like I love and love NLP. Ngrams capture local context in word order. They're used in tasks like text prediction, speech recognition, and language modeling. However, ngrams grow exponentially with n, making them less efficient for long-range context. What is POS tagging? Part of speech. POS tagging assigns grammatical roles to words such as noun, verb, or adjective. For instance, in dogs bark loudly, dogs is a noun, bark a verb, and loudly an adverb. POS tagging helps in parsing, named entity recognition, and sentiment analysis, as it gives syntactic structure to text. What is named entity recognition? NER. NER identifies and classifies entities in text into categories like person, organization, location, or date. For example, Apple released the iPhone in California would label Apple as an organization and California as a location. NER is crucial for extracting structured information from unstructured text, powering applications like search engines and question answering. What is parsing in NLP? Parsing is the process of analyzing sentence structure according to grammar rules. It helps understand how words group together and what roles they play. Parsing can be syntactic, structure, or semantic meaning. It's useful in tasks like machine translation or dialogue systems, where grammar impacts meaning. Dependency parsing versus constituency parsing. Constituency parsing breaks sentences into subphrases, noun phrases, verb phrases, in a tree structure. Dependency parsing, instead, builds relationships between words, like subject or object links. For example, in The Dog Chased the Cat, dependency parsing links dog as subject of chased. Dependency parsing is often more practical for downstream NLP tasks. What are embeddings in NLP? Embeddings are dense vector representations of words, sentences, or documents. Unlike sparse methods like BOW or TF-IDF, embeddings capture semantic meaning. Words with similar meaning are closer in vector space. Word2, VEC, GLOVE, and BERT embeddings are popular examples. Embeddings enable modern NLP tasks like semantic similarity, translation, and recommendation. Difference between Word2vec, GLOVE, and fast text. Word2vec learns embeddings by predicting context, either via CBOW or skipgram. GLOVE is based on global word co-occurrence statistics, capturing broader relationships. Fast text extends Word2vec by using subword information, allowing it to handle rare and out-of-vocabulary words better. Each method balances efficiency, context, and coverage differently. What is subword tokenization? Subword tokenization splits words into smaller units like play plus ing or un plus break plus able. This reduces the out-of-vocabulary problem since new words can be composed from known subwords. Methods like byte pair, encoding BPE, and wordpiece are used in BERT and GPT models. What is byte pair encoding BPE? BPE is a tokenization algorithm that starts with characters as units, then merges the most frequent pairs iteratively. For example, THONIE and ER may merge into there. This strikes a balance between character and word-level tokenization. BPE is widely used in NLP transformers to handle rare words effectively. What is cosine similarity in embeddings? Cosine similarity measures how similar two vectors are by computing the cosine of the angle between them. In embeddings, it tells how semantically close two words or sentences are. A cosine similarity close to 1 means high similarity, while 0 means unrelated. What is Jacquard similarity? Jacquard similarity measures overlap between two sets. In NLP, it can compare token sets of sentences. For example, I love NLP and I love AI share 2 out of 4 unique words, giving 0.5 similarity. It's simple but ignores word meaning and order. What is edit distance in NLP? Edit distance measures the number of operations, insertions, deletions, or substitutions needed to convert one string into another. For example, kitten to sitting requires 3 edits. It's used in spell correction, plagiarism detection, and fuzzy matching. The Levenstein distance is the most common version. What is language modeling? Language modeling predicts the probability distribution of word sequences. For example, in the cat sat on the model predicts likely next words. Early models used n-grams, while modern ones use RNNs, LSTMs, and transformers. Language modeling underpins applications like autocomplete, translation, and speech recognition. What is perplexity in language models? Perplexity measures how well a language model predicts a sample. Lower perplexity means better predictive power. Mathematically, it's the exponent of the average negative log likelihood. For example, a model with perplexity of 10 is less certain than one with 2. It's a standard evaluation metric in NLP. Explain smoothing in language models. Smoothing adjusts probabilities in n-gram models to handle unseen words or sequences. Without smoothing, an unseen phrase gets 0 probability. Methods include Laplace smoothing, good Turing, and Kinney's or Ney. Smoothing ensures more robust predictions, especially with sparse data. What is Zipf's law in NLP? Zipf's law states that in natural language, word frequency is inversely proportional to its rank. Common words like the appear very often, while most words are rare. This explains why NLP faces issues like data sparsity and motivates methods like subword tokenization. What is spell correction in NLP? Spell correction detects and fixes misspelled words. Methods include dictionary lookups, edit distance, and context-aware models. For example, receive. Advanced systems use embeddings in language models to choose corrections based on context, such as distinguishing there versus there. What is topic modeling? Topic modeling discovers hidden themes in a collection of documents. Each document is represented as a mixture of topics, and each topic is a distribution over words. LDA is the most common technique. Applications include document clustering, recommendation, and information retrieval. What is latent semantic analysis, LSA? Latent semantic analysis is a technique that reduces the dimensionality of text data using singular value decomposition, SVD. It captures hidden semantic structures by projecting documents and words into a lower dimensional space where similar terms and documents are closer. LSA improves search, information retrieval, and clustering by going beyond exact word matches and handling synonymy. Explain latent Dirichlet allocation, LDA. LDA is a probabilistic topic modeling algorithm. It assumes documents are mixtures of topics, and each topic is a distribution over words. By inferring these distributions, LDA uncovers hidden themes in a corpus. For example, in news articles, topics may align with politics, sports, or technology. It's widely used for document classification and recommendation. Compare LSA versus LDA. LSA uses linear algebra, SVD, to reduce dimensions and capture semantic similarity, while LDA is a probabilistic model that explicitly represents documents as topic mixtures. LSA is faster but less interpretable, while LDA provides clearer, probabilistic topic distributions. In practice, LDA is preferred for topic modeling, while LSA is used for retrieval tasks. What is pointwise mutual information? PMI. PMI measures how much the actual co-occurrence of two words differs from what would be expected if they were independent. High PMI means strong association. For example, new and York have high PMI. It's often used in word embedding construction and collocation detection. What are collocations in NLP? Collocations are pairs or groups of words that frequently occur together, such as strong T or make a decision. Identifying collocations is important because their combined meaning isn't always obvious from individual words. Techniques like PMI or statistical association measures help extract collocations for lexicons and language models. What is chunking in NLP? Chunking, or shallow parsing, groups words into higher-level phrases like noun phrases or verb phrases without building a full parse tree. For example, in The Quick Brown Fox, chunking identifies the quick brown fox as a noun phrase. It's useful in tasks like named entity recognition and information extraction. What is co-reference resolution? Co-reference resolution identifies when different expressions refer to the same entity. For instance, in Alice Went to the Park. She enjoyed it. Alice and she are co-referent. Resolving these links is crucial for tasks like question answering, summarization, and dialogue systems to maintain coherence. What are parse trees? Parse trees visually represent the syntactic structure of a sentence. Constituency parse trees break text into nested phrases, while dependency parse trees show direct word-to-word relationships. Parse trees help in grammar checking, translation, and semantic analysis by clarifying sentence structure. What is a Markov model in NLP? A Markov model represents text as a probabilistic sequence where the next state depends only on the current one. In NLP, this means predicting the next word based on the current word. Markov models are simple and form the basis of n-gram language models, though they struggle with long-range dependencies. Explain hidden Markov models HMMS. HMMS extend Markov models by introducing hidden states that generate observable outputs. In NLP, hidden states might represent POS tags and observed words or emissions. HMMS are used for tasks like POS tagging and speech recognition, where underlying states are inferred from observed sequences. Applications of HMMS in NLP. HMMS have been applied in POS tagging, named entity recognition, and speech recognition. They model sequential data by capturing probabilities of state transitions and word emissions. Although largely replaced by deep learning, HMMS laid the foundation for sequence modeling in NLP. What is CRF? Conditional random field. CRFs are probabilistic graphical models that predict sequences by considering context. Unlike HMMS, which assume independence, CRFs can use overlapping features and look at entire sequences during prediction. They're widely used in sequence labeling tasks like NER, POS tagging, and shallow parsing. Compare HMMS versus CRFs. HMMs are generative, modeling joint probability of sequences and observations, while CRFs are discriminative, directly modeling conditional probability of labels given input. CRFs handle rich, overlapping features better and usually outperform HMMS in tasks like NER and POS tagging. What is maximum entropy modeling? Maximum entropy, or maxent, models probabilities of outcomes by maximizing entropy subject to observed constraints. In NLP, maxent is used for text classification, POS tagging, and sentiment analysis. It's flexible since it doesn't assume independence and works well with diverse features. What are distributional semantics? Distributional semantics is the idea that word meaning is derived from context. Words that occur in similar contexts have similar meanings. This underpins embeddings like word-to, vec, and glove. For example, doctor and nurse often co-occur with hospital, so their vectors are close in embedding space. What is latent semantic indexing? Latent semantic indexing, LSI, applies LSA to improve information retrieval. By mapping words and documents into a latent space, it captures synonymy and reduces dimensionality. For example, a search for car may also retrieve documents about automobiles. LSI is a classic approach in search engines. What is n-gram language modeling? An n-gram language model predicts the probability of a word given the previous n-1 words. For example, a trigram model predicts today based on how are. N-grams are simple and effective, but suffer from sparsity and limited context, motivating neural approaches. What is perplexity in n-gram models? Perplexity measures how well an n-gram model predicts text. It's the inverse probability of the test set normalized by word count. Lower perplexity means better predictions. For example, a model trained on news text will have lower perplexity on similar articles than on poetry. What is backoff in n-grams? Backoff smooths probabilities when an n-gram isn't observed. For example, if a trigram is unseen, the model falls back to a bigram or unigram estimate. This ensures that every sequence has some probability, improving robustness with sparse data. What is smoothing? Laplace, Kneser, Nye. Smoothing prevents zero probabilities for unseen n-grams. Laplace smoothing adds 1 to all counts, simple but crude. Kneser, Nye smoothing is more advanced, redistributing probability mass based on context and rare events. Nezernai is considered one of the most effective smoothing methods for language models. What is TF versus TF-IDF weighting? Term frequency, TF, counts how often a word appears in a document, while TF-IDF scales this by how rare the word is across the corpus. For example, data may be frequent but still discriminative in research papers. TF-IDF is widely used in retrieval and classification tasks. Explain keyword extraction methods. Keyword extraction identifies the most relevant words or phrases in a document. Classical methods include TF-IDF, text rank, a graph-based algorithm, and statistical approaches like PMI. Keyword extraction supports summarization, tagging, and search indexing. Applications of regex in NLP. Regular expressions are used for pattern matching, such as extracting dates, emails, or phone numbers from text. They're also useful for pre-processing, like cleaning HTML tags or normalizing tokens. While regex is powerful, it's limited in handling natural language complexity compared to statistical models. Limitations of classical NLP methods. Classical methods rely heavily on handcrafted features, struggle with polysemy and context, and don't generalize well across domains. They often ignore word order and semantics. While effective for small tasks, they're outperformed by deep learning methods that learn representations automatically from data. Why deep learning improved NLP? Deep learning revolutionized NLP by replacing manual feature engineering with automatically learned embeddings and architectures like RNNs, LSTMs, and transformers. These models capture long-range context, semantics, and syntax more effectively. As a result, tasks like translation, summarization, and QA saw massive accuracy jumps over classical methods. What are RNNs in LP? Recurrent neural networks, or RNNs, are designed to handle sequential data like text. They process input one token at a time while maintaining a hidden state that carries information from previous steps. This allows them to model word dependencies in sentences. However, RNNs struggle with long-range dependencies due to vanishing or exploding gradients, which later architectures like LSTMs addressed. Explain LSTM in NLP. Long short-term memory networks are a type of RNN designed to overcome vanishing gradients. They use gates, input, forget, and output, to control how information is stored, updated, or discarded. This allows LSTMs to capture longer dependencies in text, making them effective for tasks like machine translation, sentiment analysis, and speech recognition. What is GRU in NLP? Gated recurrent units, GRUs, are a simpler alternative to LSTMs. They combine the input and forget gates into a single update gate, making them computationally lighter while still addressing vanishing gradients. GRUs often perform as well as LSTMs with fewer parameters, making them popular in real-time NLP applications. Compare LSTM versus GRU. Both LSTMs and GRUs handle long-term dependencies better than vanilla RNNs. LSTMs are more expressive due to 3 gates and a separate memory cell, while GRUs are simpler and faster with only 2 gates. In practice, GRUs train faster on smaller datasets, while LSTMs may generalize better on larger or more complex tasks. What is sequence-to-sequence modeling? Sequence-to-sequence, or Sec2 SEQ, models transform an input sequence into an output sequence, often with different lengths. For example, translating an English sentence into French. Typically, an encoder processes the input into a context vector, and a decoder generates the output. Attention mechanisms later improve Sec2-Sec by addressing the bottleneck of a single context vector. What is attention in NLP? Attention allows models to focus on the most relevant parts of an input sequence when generating output. Instead of compressing an entire input into one vector, attention assigns weights to each token, so the model can attend to important words dynamically. This dramatically improved translation, summarization, and other sequence-to-sequence tasks. Explain self-attention mechanism. Self-attention computes relationships between all tokens in a sequence to capture context. Each token generates query, key, and value vectors, and attention scores are calculated to determine how much each token contributes to another. This mechanism underpins transformer models, allowing them to model global dependencies efficiently. What is transformer architecture? The transformer architecture, introduced in Attention is All You Need, eliminates recurrence and instead relies on self-attention and feed-forward layers. It processes tokens in parallel, enabling scalability and capturing long-range dependencies more effectively. Transformers form the backbone of modern NLP models like BERT, GPT, and T5. What is positional encoding in transformers? Since transformers don't have recurrence or convolution, they use positional encodings to inject information about token order. These encodings are added to input embeddings and can be sinusoidal or learned vectors. This ensures the model knows whether a word appears at the start, middle, or end of a sentence. What is multi-head attention? Multi-head attention runs multiple self-attention operations in parallel, each learning different types of relationships between tokens. For example, one head may capture subject-verb relationships, while another focuses on adjectives. Outputs are concatenated and projected, giving the model richer context representations. Compare transformers versus RNNs. RNNs process sequences step by step, which limits parallelization and struggles with long dependencies. Transformers use self-attention, capturing global context in a single step and enabling parallel computation. This makes transformers faster, more scalable, and more accurate on large NLP benchmarks, though RNNs may still be used in low-resource settings. What is BERT? BERT, bidirectional encoder, representations from transformers, is a pre-trained transformer model that learns deep bidirectional context using mask language modeling and next sentence prediction. It's fine-tuned for tasks like classification, NER, and QA. BERT revolutionized NLP by providing general-purpose embeddings that significantly improved downstream task performance. What is GPT? GPT, Generative Pre-trained Transformer, is a unidirectional transformer model pre-trained with causal language modeling. Unlike BERT, which is encoder-based, GPT is decoder-based, making it better at text generation. GPT models power conversational AI, summarization, and creative text tasks. Later versions scaled massively, driving breakthroughs in generative AI. What is XLNet? XLNet is a transformer model that combines the strengths of BERT and autoregressive models. It uses permutation-based training, considering all possible word orders during pre-training. This overcomes BERT's limitations by modeling bidirectional context without masking. XLNet achieves state-of-the-art results on many NLP benchmarks when released. What is T5 in NLP? T5, or text-to-text transfer transformer, frames every NLP task as text-to-text. For example, classification is phrased as input, sentence, output, label. This unifies tasks under a single architecture, simplifying training and fine-tuning. T5 showed the power of treating all NLP problems as sequence-to-sequence generation. What is Roberta? Roberta is a robustly optimized version of BERT. It removes next sentence prediction, uses more data, larger batches, and longer training. The result is a stronger baseline that outperforms BERT on many benchmarks. Roberta demonstrated how training optimizations can significantly boost model performance without architectural changes. What is Albert? Albert is a lightweight variant of BERT that reduces parameters through factorized embeddings and cross-layer parameter sharing. Despite being smaller, Albert maintains competitive performance, making it efficient for large-scale deployment. It's a great example of scaling down without sacrificing much accuracy. What is Electra? Electra replaces masked token prediction with a more efficient pre-training task, distinguishing real tokens from those generated by a small generator. This discriminative approach makes Electra much faster to train while achieving performance similar to or better than BERT. It's resource efficient for pre-training. What is Distill BERT? Distill BERT is a distilled, smaller version of BERT. Using knowledge distillation, it compresses BERT into a lighter model with fewer parameters while retaining about 95% of its performance. Distill BERT is widely used in applications requiring efficiency, like mobile NLP or low-latency APIs. What is sentence embedding? Sentence embeddings represent entire sentences as dense vectors in semantic space. Unlike word embeddings, they capture meaning at sentence level. Approaches include averaging word embeddings, using BERT's CLS token, or models like SentenceBERT. Sentence embeddings are crucial for semantic similarity, clustering, and retrieval. Explain Siamese networks for NLP. Siamese networks use two identical models with shared weights to generate embeddings, then compare them for similarity. In NLP, they're used for tasks like paraphrase detection or semantic similarity. For example, SentenceBERT applies a Siamese architecture to compare sentence embeddings efficiently. What is semantic similarity in NLP? Semantic similarity measures how close two pieces of text are in meaning, not just surface form. Embeddings and similarity measures like cosine similarity are used to evaluate it. Applications include search engines, duplicate detection, and recommendation systems. What is masked language modeling? Masked language modeling, used in BERT, hides some words in a sentence and trains the model to predict them based on context. For example, the cat on the mat sat. This forces the model to learn bidirectional context, improving representation quality. What is causal language modeling? Causal language modeling predicts the next token given all previous ones, as in GPT. It's strictly left to right, making it ideal for text generation tasks. Unlike masked modeling, it doesn't look at future tokens, ensuring outputs are generated sequentially. Applications of transformers in NLP. Transformers power nearly all modern NLP tasks: translation, summarization, question answering, sentiment analysis, chatbots, and even multimodal tasks like text-to-image. Their ability to scale with data and compute has made them the foundation of today's NLP and generative AI revolution. What is text classification? Text classification assigns predefined categories to documents, such as spam versus non-spam in emails, or positive versus negative in sentiment analysis. Classical methods use bag of words with logistic regression or SVMs, while modern systems use deep learning models like CNNs, RNNs, or transformers. It's one of the most fundamental and widely used applications of NLP. What is sentiment analysis? Sentiment analysis determines the emotional tone of text, such as positive, negative, or neutral. Businesses use it to analyze customer reviews, monitor brand reputation, or understand social media trends. While simple at the sentence level, real-world sentiment analysis must handle sarcasm, context, and domain-specific language. What is spam detection? Spam detection classifies emails or messages as spam or not spam. It uses NLP to detect patterns in text, sender information, and metadata. Early models relied on rules and keywords, while modern systems use machine learning and embeddings. Spam detection is critical in communication systems for security and user trust. What is question answering QA? QA systems retrieve or generate answers to user queries. Extractive QA highlights spans of text from documents, while abstractive QA generates answers in natural language. Transformer-based models like BERT and GPT have made Q a highly effective, powering virtual assistants, search engines, and chatbots. What is machine translation? Machine translation automatically converts text from one language to another. Early systems used rule-based or statistical approaches, while today's systems use neural machine translation with transformers. Models like Google Translate or DeepL achieve near-human quality, though challenges remain in handling low-resource languages and cultural nuance. What is summarization? Summarization condenses long text into shorter versions, while retaining key information. Extractive summarization selects important sentences, while abstractive summarization generates new text. Applications include summarizing research papers, news articles, or customer feedback. With models like GPT and BERT, abstractive summarization has become highly effective. What is extractive versus abstractive summarization? Extractive summarization selects key sentences from the text without rewriting them. Abstractive summarization, like how humans summarize, generates new sentences that capture the essence. Extractive is simpler and more reliable, while abstractive is more natural but harder to train and evaluate. What is conversational AI? Conversational AI refers to systems like chatbots and virtual assistants that engage in natural dialogue with humans. They combine NLP, dialogue management, and sometimes speech recognition. Advanced conversational AI uses large language models to maintain context, handle complex queries, and generate natural responses. What are chatbots? Chatbots are conversational agents that interact with users through text or speech. They can be rule-based, responding with pre-programmed scripts, or AI-driven, using NLP to understand intent and generate responses. Chatbots are widely used in customer service, healthcare, and e-commerce to provide 24/7 support. What is intent recognition? Intent recognition identifies the goal behind a user's input, such as book a flight or check account balance. It's a key component of dialogue systems. Classifiers trained on labeled intent data map queries to predefined categories, enabling the system to trigger the correct response or action. What is slot filling in dialogue systems? Slot filling extracts specific details from user queries to complete tasks. For example, in Book Me a Flight from New York to London, slots include origin equals New York and destination equals London. Together with intent recognition, slot filling powers task-oriented dialogue systems. What is knowledge graph construction? Knowledge graphs represent entities and their relationships in graph form. NLP extracts entities from text, links them, and builds a structured knowledge base. For example, from Einstein developed relativity, the graph links Einstein to develop to relativity. Knowledge graphs support search, recommendations, and reasoning. What is text entailment? Text entailment, or natural language inference, determines if a hypothesis logically follows from a premise. For example, premise, all cats are animals. Hypothesis, my pet cat is an animal. Entailed, it's important in QA, summarization, and reasoning tasks. What is natural language inference, NLI? NLI is the formal task of determining whether a hypothesis is entailed, contradicted, or neutral with respect to a premise. Large data sets like SNLI and MNLI train models for NLI. It's a benchmark for evaluating how well models understand logical relationships in text. What is text generation? Text generation produces coherent text given an input or context. Early systems use statistical language models, while modern systems use GPT like transformers. Applications include autocomplete, creative writing, summarization, and conversational AI. The challenge is balancing fluency, relevance, and factual correctness. What is controlled text generation? Controlled text generation steers outputs toward specific attributes like sentiment, length, or style. Techniques include conditioning on labels, prompts, or fine-tuning with control codes. For example, generating positive movie reviews or limiting answers to 100 words. It's key for safe and tailored text generation. What is neural machine translation, NMT? NMT uses neural networks, typically transformers, to translate text end-to-end. Unlike phrase-based statistical machine translation, NMT learns contextual embeddings and generates fluent translations. Systems like Google Translate rely on NMT. While highly accurate, challenges remain with rare words, idioms, and low-resource languages. What is beam search in NMT? Beam search is a decoding algorithm that keeps track of the top K most likely sequences at each step, rather than only the best. This balances exploration and exploitation, often producing more fluent translations than greedy search. Beam size controls the trade-off between quality and computation. What is greedy decoding? Greedy decoding selects the most likely next token at each step. It's fast and simple, but can lead to suboptimal sequences since it doesn't consider long-term context. For example, it may generate shorter, less coherent sentences compared to beam search. What is temperature in text generation? Temperature controls randomness and sampling. A high temperature greater than 1 increases diversity by flattening probabilities, making outputs more creative but less predictable. A low temperature less than 1 sharpens probabilities, making outputs more deterministic. Adjusting temperature balances creativity and control in text generation. What is top K and nucleus sampling? Top K sampling restricts generation to the K most likely tokens at each step, while nucleus sampling, top P, selects from the smallest set of tokens whose cumulative probability exceeds P. Both introduce randomness while maintaining coherence. They're widely used in modern text generation for more natural outputs. What is text similarity search? Text similarity search retrieves documents or passages semantically close to a query. Embeddings represent text in vector space, and similarity measures like cosine distance identify matches. This powers semantic search, recommendation engines, and RAG pipelines for LLMs. Applications of NLP in healthcare. NLP processes clinical notes, extracts medical entities, and supports decision-making. For example, it can flag medication conflicts, summarize patient histories, or analyze radiology reports. Privacy, interpretability, and domain adaptation are critical for healthcare. NLP. Applications of NLP in finance. In finance, NLP analyzes earnings reports, news and social media for sentiment and risk signals. It powers fraud detection, customer support chatbots, and compliance monitoring. Real-time language analysis helps financial institutions make data-driven investment decisions. Applications of NLP in legal industry. In law, NLP supports contract analysis, case retrieval, and e-discovery. Models extract clauses, detect risks, and summarize legal documents. This saves time for lawyers and reduces errors. Challenges include domain-specific terminology and the high stakes of misinterpretation. What is BLEU score? BLEU, Bilingual Evaluation Understudy, is a metric for evaluating machine translation by comparing generated output against reference translations. It measures n-gram overlap, penalizing shorter outputs. A BLEU score closer to 1 indicates higher similarity. While widely used, it struggles with synonyms and doesn't capture meaning fully. What is ROUGE score? ROUGE, Recall-Oriented Understudy for Gist Evaluation, is commonly used for summarization tasks. It compares the overlap of n-grams, word sequences, or word pairs between generated and reference summaries. Unlike BLEU, which emphasizes precision, ROUGE focuses on recall, making it suitable for tasks where coverage of key content matters. What is METEOR score? METEOR evaluates text generation by considering exact matches, stemmed matches, synonyms, and paraphrases. Unlike BLEU, which only counts overlaps, METEOR accounts for semantic similarity, making it more aligned with human judgment. It's especially useful in translation and summarization tasks. What is CIDER in NLP? CIDER, Consensus-Based Image Description Evaluation, is designed for image captioning. It measures how well a generated caption matches multiple human references using weighted n-gram similarity. It rewards consensus among human-written captions, aligning better with real-world descriptive tasks. What is perplexity? Perplexity measures how well a language model predicts a sample. It's the exponent of the average negative log likelihood of the test data. Lower perplexity means the model assigns higher probability to the correct sequence. It's widely used for evaluating language models, though it doesn't always correlate with human judgment of fluency. Explain accuracy versus F1 score in NLP. Accuracy measures the percentage of correct predictions, but in imbalanced data sets, it can be misleading. F1 score balances precision, how many predicted positives are correct, and recall, how many actual positives were found. In NLP tasks like sentiment classification or NER, F1 is often preferred over raw accuracy. What is precision versus recall in NLP tasks? Precision is the fraction of correct positive predictions among all positive predictions, while recall is the fraction of correct positives identified among all actual positives. For example, in spam detection, high precision means few false alarms, while high recall means catching most spam. The balance depends on application needs. What is confusion matrix in NLP? A confusion matrix visualizes classification results across predicted versus actual labels. It shows true positives, true negatives, and false negatives. In NLP, confusion matrices help diagnose where a model confuses categories, such as mixing neutral and positive sentiment. What is Matthews correlation coefficient? MCC is a metric that considers all four outcomes of a confusion matrix. It's especially useful for imbalanced data sets, providing a balanced measure between -1, complete disagreement, and +1, perfect prediction. In NLP classification tasks, MCC offers a more reliable metric than accuracy alone. What is word error? Rate WER. WER measures errors in speech recognition by calculating the number of insertions, deletions, and substitutions needed to transform predicted transcripts into the reference. Lower WER indicates better performance. It's the standard metric for ASR systems, but can penalize harmless differences like synonyms. What is character error? Rate CER. CER is similar to WER, but evaluates at the character level. It's useful for languages with no spaces between words like Chinese, or for OCR systems. CER provides finer-grained evaluation than WER, especially for short texts. What is BERTScore? BERTScore uses contextual embeddings from BERT to compare generated text with references. Instead of surface-level n-gram overlap, it measures semantic similarity between embeddings. This makes it more robust for paraphrases and synonyms, aligning better with human evaluation than BLEU or ROUGE. What is human evaluation in NLP? Human evaluation involves asking people to judge the quality of generated text based on fluency, adequacy, and relevance. It's the gold standard since automatic metrics can't capture nuance fully. However, it's time-consuming, costly, and less scalable, so it's often combined with automated metrics. Compare automatic versus human evaluation. Automatic metrics like BLEU or ROUGE are fast, consistent, and scalable, but may miss meaning or creativity. Human evaluation captures nuance, coherence, and appropriateness, but is slow and subjective. In practice, researchers use both, automatic metrics for quick feedback and human judgments for final validation. Challenges in evaluating generative models. Generative models can produce fluent but factually incorrect text, making evaluation tricky. Automatic metrics often fail to capture factual accuracy, creativity, or safety. Human evaluation is better but costly. New metrics like BERTScore and QRFs aim to assess semantics and factual consistency, but evaluation remains an open challenge. What is adversarial evaluation in NLP? Adversarial evaluation tests models with deliberately challenging inputs, such as paraphrase questions or misspellings. The goal is to reveal weaknesses in robustness. For example, QA systems might fail if synonyms are used. Adversarial evaluation ensures models generalize beyond clean training data. Explain K-fold cross-validation in NLP. K-fold cross-validation splits data into K-folds, training on K1 and testing on the remaining fold, repeating K times. This reduces variance from a single train test split and provides a more reliable estimate of model performance, especially on smaller NLP datasets. What is train, dev, and test split in NLP? Data is typically divided into training, development validation, and test sets. The training set is used for learning, the dev set for tuning hyperparameters, and the test set for final evaluation. Proper splitting prevents overfitting and ensures fair assessment of generalization. What is overfitting in NLP? Overfitting occurs when a model learns noise and specifics of the training data rather than general patterns. For example, memorizing training sentences but failing on new text. It's mitigated by regularization, dropout, data augmentation, or early stopping. Explain cross-lingual evaluation. Cross-lingual evaluation assesses how models trained in one language perform in another. For example, a multilingual BERT model may be tested on English and Spanish tasks. It's crucial for low-resource languages, though evaluation is harder due to fewer benchmarks. What is multilingual benchmarking? Multilingual benchmarking tests NLP models across many languages using standardized datasets. Examples include XGLUE and XTREME. These benchmarks reveal strengths and weaknesses in cross-lingual transfer, guiding improvements in multilingual models. What is GLUE benchmark? GLUE General Language Understanding Evaluation is a benchmark suite with tasks like sentiment classification, NLI, and paraphrase detection. It became a standard for evaluating pre-trained models. GLUE accelerated progress in NLP, though many models now surpass human baselines. What is Super GLUE? Super GLU is a harder benchmark than GLU, designed after models saturated GLU performance. It includes more challenging tasks like common sense reasoning and multi-sentence inference. Super GLU better reflects the complexity of real-world language understanding. What is HELM benchmark? HELM, Holistic Evaluation of Language Models, is a recent framework that evaluates language models across multiple dimensions: accuracy, robustness, fairness, efficiency, and more. It acknowledges that NLP models must be assessed beyond accuracy alone, considering their broader societal impact. Why evaluation in NLP is difficult? Language is complex with multiple valid ways to express meaning. Metrics like BLEU may penalize correct but differently worded outputs. Generative models introduce further challenges with creativity and factuality. Human evaluation helps but is costly. Designing universal, reliable metrics remains an ongoing challenge in NLP research. What is inference in NLP? Inference in NLP is the process of applying a trained model to new, unseen input to generate predictions. For example, feeding a sentence into a sentiment classifier to output positive or negative inference is distinct from training. It must be faster, efficient, and often runs under strict latency constraints in production systems. What is latency in NLP inference? Latency is the time between providing input to an NLP model and receiving output. Low latency is critical for real-time applications like chatbots, translation, or voice assistants. Optimizing latency involves model compression, hardware acceleration, caching, and batching strategies without sacrificing too much accuracy. What is batch inference in NLP? Batch inference processes multiple inputs simultaneously in one forward pass. For example, predicting sentiment for 1,000 reviews at once, it maximizes hardware utilization, especially on GPUs, reducing cost and throughput time. However, it's less suitable for interactive systems that require real-time responses. What is streaming inference? Streaming inference processes inputs token by token or chunk by chunk, instead of waiting for the entire input. This is vital in speech recognition or long document summarization, where users expect partial outputs quickly. Transformers optimized with caching enable efficient streaming inference in production. How to optimize NLP models for mobile. Optimizing NLP for mobile involves reducing model size and computational costs. Techniques include quantization, pruning, and distillation. Architectures like Distill-BERT, Mobile BERT, and TinyBERT are designed for on-device use. Efficient mobile NLP powers applications like predictive keyboards, translation, and voice assistants. What is pruning in NLP models? Pruning removes unnecessary weights, neurons, or even entire layers from a model to make it smaller and faster. For example, in transformers, less important attention heads can be pruned. The challenge is maintaining accuracy while improving efficiency, especially for deployment on resource-constrained devices. What is quantization in NLP models? Quantization reduces the precision of weights and activations from 32-bit floats to lower formats like 16-bit or 8-bit integers. This lowers memory and compute requirements, making models faster and cheaper to deploy. Quantization-aware training helps preserve accuracy during this process. What is distillation in NLP models? Knowledge distillation compresses large models by transferring knowledge from a teacher model to a smaller student model. The student learns from soft probabilities instead of hard labels, capturing richer information. Distillation is widely used to deploy efficient models like Distill-BERT while retaining much of the teacher's accuracy. What is caching in NLP inference? Caching stores intermediate results to avoid recomputation. For example, in transformers, key value pairs from previous tokens can be cached during autoregressive generation. This speeds up long sequence processing, reducing both latency and compute costs in production systems. What is ONNX in NLP? ONNX, Open Neural Network Exchange, is an open standard that allows NLP models trained in one framework, like PyTorch, to be exported and deployed in another environment. It ensures portability and enables hardware optimizations, simplifying scaling across diverse platforms. What is TensorRT for NLP? TensorRT is NVIDIA's optimization toolkit for deploying deep learning models on GPUs. For NLP, it speeds up inference by fusing layers, reducing precision, and tuning kernels. It's particularly effective for large transformer models where GPU acceleration is essential. What is Hugging Face Transformers? Hugging Face Transformers is a widely used library providing pre-trained NLP models like BERT, GPT, and T5. It standardizes APIs for training, fine-tuning, and deployment, accelerating research and industry adoption. Its ecosystem also supports pipelines, datasets, and model sharing. What is TorchServe for NLP? TorchServe is a model-serving framework for PyTorch models. In NLP, it allows you to deploy models like BERT or GPT as APIs with features like versioning, logging, and scaling. It bridges the gap between model development and production deployment. What is TensorFlow serving in NLP? TensorFlow serving deploys TensorFlow models as scalable, production-ready services. In NLP, you can expose models for tasks like text classification or translation via REST or gRPC APIs. It supports A/B testing, versioning, and integrates well with cloud services. What is edge deployment in NLP? Edge deployment runs NLP models directly on local devices like phones, IoT devices, or embedded systems, instead of the cloud. Benefits include lower latency, privacy preservation, and offline functionality. Compact models like TinyBERT make edge NLP practical. What is multilingual deployment? Multilingual deployment involves serving models capable of handling multiple languages. This requires either training one large multilingual model, like MBERT or ESLMR, or deploying multiple language-specific models. The choice depends on scale, latency, and resource constraints. What is pipeline parallelism in NLP? Pipeline parallelism splits large NLP models across multiple GPUs or devices, processing different layers in sequence. While one stage processes input, the next processes intermediate results. It's used to train and deploy very large models that cannot fit on a single GPU. What is data parallelism in NLP? Data parallelism replicates the NLP model across devices, each processing different subsets of data simultaneously. Gradients are aggregated and synchronized across devices. This speeds up training and enables large batch inference, but requires strong hardware and communication overhead management. What is model parallelism in NLP? Model parallelism splits different parts of a model across multiple devices, unlike data parallelism, which splits data. For example, one GPU may process encoder layers and another the decoder. This allows training or deploying very large NLP models that wouldn't fit in a single device's memory. How to deploy conversational AI at scale. Scaling conversational AI involves combining NLP models with dialogue management, caching, and load balancing. Models are served through APIs, often using frameworks like TorchServe or TensorFlow serving. Scaling also requires monitoring latency, retraining with feedback, and ensuring resilience in production environments. What is fine-tuning versus few-shot prompting? Fine-tuning adapts a pre-trained NLP model on labeled task-specific data, requiring retraining. Few-shot prompting instead leverages a large pre-trained model by providing examples in the prompt without weight updates. Fine-tuning yields stronger, customized models while prompting is faster and data efficient. What is Retrieval Augmented Generation (RAG)? RAG combines a retriever with a generator. The retriever fetches relevant documents and the generator conditions its output on them. This makes NLP systems more grounded, factually accurate, and capable of handling long-tail knowledge beyond their training data. What is vector database for NLP? Vector databases like Pinecone, Weaviate, or FAISS store embeddings of text for fast similarity search. In NLP, they enable semantic search, RAG pipelines, and recommendation systems by quickly retrieving nearest neighbors in high-dimensional space. What is semantic search deployment? Semantic search retrieves results based on meaning rather than exact keyword match. Embeddings represent documents and queries and similarity search finds matches. Deploying semantic search requires vector storage, indexing, and scalable APIs for real-time query handling. What is hybrid retrieval in NLP? Hybrid retrieval combines keyword-based search, example is BM25, with embedding-based semantic search. This balances precision from lexical matching with recall from semantic similarity. Hybrid retrieval is widely used in production RAG pipelines in enterprise search systems. Why is interpretability important in NLP? Interpretability is important because NLP models often influence high-stakes decisions, like medical diagnoses or legal recommendations. Stakeholders need to understand why a model made a prediction to trust its output. Without interpretability, even accurate systems may be rejected due to lack of transparency, accountability, and fairness. What is attention visualization? Attention visualization shows which tokens a transformer-based NLP model is focusing on when making predictions. For example, in translation, attention maps reveal word alignments between source and target. It helps researchers debug models and provides interpretability for end users. What is SHAP in NLP? SHAP, SHAPL, EYIDDITIVEEXPLANATIONS is a model-agnostic method that assigns important scores to features based on Shapley values from game theory. In NLP, SHAP can highlight which words contributed most to a classification, such as detecting which terms led to a spam label in email filtering. What is LIME in NLP, LIME, Local Interpretable Model Agnostic Explanations, explains predictions by approximating a model locally with a simpler interpretable one. In NLP, LIME perturbs input text by removing or altering words and observes output changes, showing which words influence the decision most. What is bias in NLP models? Bias in NLP refers to systematic unfairness in predictions, often stemming from skewed training data. For instance, a resume screener trained on biased data may prefer male applicants. Bias can appear in embeddings, classification, or generation. Detecting and mitigating it is essential for ethical NLP. What is fairness in NLP? Fairness means ensuring NLP models perform equitably across different groups, such as gender, race, or language communities. For example, sentiment analysis should not systematically misclassify text from certain dialects. Fairness audits, balanced datasets, and debiasing techniques are used to improve fairness. Examples of bias in word embeddings. Word embeddings trained on large corpora often reflect societal biases. For example, man may be closer to doctor, while woman is closer to nurse. These associations can reinforce stereotypes in downstream applications. Such biases highlight the need for debiasing techniques. What is debiasing in NLP? Debiasing techniques aim to reduce harmful associations in embeddings or models. Methods include removing gender directions from embedding spaces, balancing datasets, or adversarial training. While debiasing can reduce bias, ensuring fairness without losing useful semantic information remains challenging. What is toxic content generation in NLP? Toxic content generation occurs when NLP models produce offensive, harmful, or unsafe language. This can happen if models are trained on unfiltered web data. Toxic outputs are a major risk in chatbots and content generation systems requiring filtering and safety layers. How to mitigate toxicity in NLP models. Toxicity can be mitigated with data filtering, reinforcement learning from human feedback, RLHF, content moderation filters, and controlled generation techniques. Continuous monitoring is also necessary, as no model is completely safe out of the box. What is hallucination in NLP models? Hallucination refers to NLP models generating fluent but factually incorrect outputs. For example, a model might invent non-existent references in a summary. This is common in generative models and is a major concern for applications requiring factual reliability. Why is hallucination dangerous in NLP? Hallucinations are dangerous because users may trust AI-generated text that looks confident and fluent, even if it's false. In fields like healthcare, law, or finance, this can cause serious harm. Reducing hallucination through grounding, retrieval, or factuality checks is essential. What is adversarial attack in NLP? Adversarial attacks involve crafting small, often imperceptible changes in text that fool NLP models. For example, inserting typos in spam emails can bypass spam filters. Such attacks expose vulnerabilities and highlight the need for robust NLP systems. What is data poisoning in NLP? Data poisoning is when malicious actors inject corrupted or biased data into training corpora, altering model behavior. For instance, poisoning a chatbot's training data with offensive text could make it generate harmful outputs. Defenses include data validation and anomaly detection. What are privacy risks in NLP? NLP models trained on sensitive text data may inadvertently memorize and leak private information, such as phone numbers or medical records. Attacks like model inversion can extract such data. Privacy-preserving techniques like differential privacy and federated learning mitigate these risks. What is federated learning in NLP? Federated learning trains models across distributed devices holding local data without transferring it to a central server. In NLP, this allows personalization, example is predictive keyboards, while preserving privacy. Gradients, not raw data, are shared, reducing privacy risks but increasing communication overhead. What is responsible NLP? Responsible NLP ensures that systems are fair, transparent, safe, and aligned with human values. It emphasizes accountability, ethical data use, and safeguards against misuse. Responsible NLP isn't just a technical issue. It requires governance, policy, and social considerations. What are ethical risks in healthcare NLP? Healthcare NLP risks include biased diagnosis, misinterpretation of clinical notes, and patient privacy violations. An incorrect or unfair prediction can have life-threatening consequences. Ensuring fairness, interpretability, and compliance with regulations like HIPAA is critical in this domain. What are ethical risks in surveillance NLP? NLP and surveillance, such as monitoring conversations or social media, risks mass surveillance, censorship, and misuse by authoritarian regimes. It raises concerns around privacy and civil liberties. Ethical deployment requires transparency, legal oversight, and clear boundaries. Explainable NLP. Explainable NLP refers to techniques that make model decisions transparent and interpretable. Examples include highlighting influential words, showing attention maps, or using simpler surrogate models. Explainability builds trust and helps debug errors in complex NLP systems. What is model interpretability versus explainability? Interpretability refers to how understandable the internal mechanics of a model are. For example, linear regression is highly interpretable. Explainability refers to external tools and methods used to explain otherwise opaque models like transformers. Both are essential in NLP for trust and accountability. What are social risks of NLP models? NLP models can amplify misinformation, reinforce stereotypes, or spread toxic language. They may also marginalize underrepresented groups if trained on biased data. Addressing social risks requires diverse data, fairness testing, and careful deployment practices. What is accountability in NLP systems? Accountability means defining who is responsible when NLP systems cause harm: developers, companies, or regulators. It involves clear documentation, monitoring, and the ability to trace decisions. Accountability is critical to ensure responsible adoption of NLP. What is transparency in NLP research? Transparency means openly sharing model architectures, training datasets, evaluation methods, and limitations. This allows others to replicate results, identify biases, and improve upon systems. Transparency builds trust in both research and deployed NLP models. Future challenges in NLP ethics. Future challenges include balancing innovation with safety, handling multilingual fairness, preventing misuse of generative models, and addressing environmental costs of training large models. Ensuring responsible NLP will require interdisciplinary efforts across AI research, law, and social sciences. What is the future of NLP research? The future of NLP research lies in building models that are more generalizable, interpretable, and efficient. We're moving beyond task-specific fine-tuning toward foundation models capable of adapting to many domains with minimal supervision. Key directions include multimodal integration, low-resourcey language support, reasoning abilities, and ethical alignment. The next frontier is making NLP systems not just powerful, but also trustworthy and socially responsible. What are foundation models in NLP? Foundation models are large pre-trained models, like GPT or BERT variants, trained on massive text corpora. They serve as a base that can be fine-tuned or prompted for downstream tasks. Their strength is in scalability and transfer learning, enabling rapid adaptation to new applications. However, they raise challenges around bias, resource demands, and governance, making responsible use as important as technical progress. What is large-scale pre-training in NLP? Large-scale pre-training involves training NLP models on billions of words to learn general language patterns before adapting them to specific tasks. This shift has powered breakthroughs like BERT and GPT. Pre-training captures syntax, semantics, and world knowledge, dramatically improving downstream performance. The future challenge is making pre-training more data efficient and sustainable without losing power. What is zero-shot NLP? Zero-shot NLP means solving a task without seeing labeled training data for it. For example, using a pre-trained language model to classify sentiment by framing the task as a natural language prompt. Zero-shot capability reduces dependence on costly labeled datasets and makes NLP more scalable across domains and languages. What is few-shot NLP? Few-shot NLP enables models to learn tasks from only a handful of examples. By conditioning on demonstrations and prompts, large models can adapt quickly without retraining. Few-shot learning bridges the gap between zero-shot generalization and full fine-tuning, making NLP more accessible in low-data domains. What is instruction tuning? Instruction tuning is the process of fine-tuning large models on datasets of instructions and responses, teaching them to follow human commands better. This makes models more aligned, user-friendly, and versatile. It's a key step in systems like InstructGPT, which improve controllability and usefulness in real-world applications. What is prompt engineering in NLP? Prompt engineering is the art of crafting effective inputs to guide model behavior. Instead of retraining, prompts shape how the model responds. Techniques include zero-shot prompts, few-shot examples, and role-based instructions. Prompt engineering is now a critical skill for leveraging large language models in practice. What are chain-of-thought prompts? Chain-of-thought prompting guides models to reason step by step, rather than jumping straight to answers. For example, in arithmetic or logic tasks, the prompt includes intermediate reasoning steps. This improves accuracy on complex problems by encouraging structured reasoning, making models more transparent and reliable. What is role prompting in NLP? Role prompting assigns a persona or role to the model to influence its responses. For example, you are a financial advisor or act as a teacher. Role prompting makes outputs more contextual, domain-specific, and aligned with user expectations, enhancing personalization and usability. What is retrieval-augmented NLP? Retrieval-augmented NLP combines language models with external knowledge sources. Instead of relying only on memorized information, the model retrieves relevant documents and uses them to ground its answers. This reduces hallucinations and improves factual accuracy, making it essential for enterprise search, chatbots, and knowledge-intensive tasks. What are multimodal language models? Multimodal language models process and generate across multiple input types, like text, images, or audio. For example, CLIP aligns text and images, while GPT-4 can take both text and images as input. Multimodality makes AI more versatile, enabling applications like visual question answering, captioning, and AR/VR assistance. What is cross-lingual NLP? Cross-lingual NLP focuses on transferring knowledge from high-resource languages like English to low-resource ones. Multilingual pre-trained models like MBERT and XLMR enable cross-lingual transfer, where training on one language boosts performance in another. This helps scale NLP globally and reduce the digital divide. What is low-resource language NLP? Low-resource language NLP tackles challenges where little labeled or unlabeled data exists. Approaches include transfer learning, multilingual models, and synthetic data generation. Supporting low-resource languages is critical for making NLP equitable and inclusive across the globe. What is lifelong learning in NLP? Lifelong learning, or continual learning, enables models to learn new tasks without forgetting old ones. For NLP, this means adapting to new domains or languages while preserving existing knowledge. It's a step toward more human-like learning, but requires solutions to problems like catastrophic forgetting. What is self-supervised NLP? Self-supervised NLP leverages unlabeled text to create training signals automatically. Tasks like predicting masked words or next sentences generate supervision from raw data. This paradigm has fueled the success of models like BERT and GPT, making it the backbone of modern NLP. What is active learning in NLP? Active learning reduces labeling costs by selecting the most informative samples for annotation. For example, a model might request labels for ambiguous or uncertain sentences. This approach makes NLP model training more efficient, especially in domains where labeled data is expensive or scarce. What is continual learning in NLP? Continual learning is the ability of NLP models to update knowledge over time as new data arrives. Unlike static training, continual learning adapts dynamically, which is crucial for domains like news or finance, where information changes rapidly. It prevents models from becoming outdated. What is human-AI collaboration in NLP? Human-AI collaboration means designing NLP systems that complement human decision-making rather than replace it. Examples include AI-assisted writing tools, medical NLP systems that support doctors, and legal assistants that summarize documents. The goal is synergy. Humans provide judgment, while AI handles scale and speed. What is the role of NLP in AGI? NLP is central to artificial general intelligence because language is key to human reasoning and communication. Mastering NLP enables machines to understand context, abstract concepts, and interact naturally. While we're far from AGI, advances in NLP, especially with multimodal and reasoning models, bring us closer. What is the biggest open problem in NLP? One of the biggest open problems is grounded understanding. Ensuring models not only generate fluent text, but also reason correctly and factually. Hallucinations, bias, and lack of explainability remain major hurdles. Another open challenge is scaling NLP to all languages, not just English. Future applications of NLP in daily life. NLP will increasingly power everyday tools, smarter assistants, personalized tutors, AI-driven healthcare, and even real-time translation in conversations. The technology will fade into the background, enabling seamless human-AI communication across work, education, and entertainment. Future of NLP in creative industries. NLP is already transforming creative industries through AI-assisted storytelling, script writing, and marketing. In the future, it will collaborate with humans to co-create novels, music lyrics, and interactive narratives. The challenge is balancing creativity with authenticity and ethical use. Future of NLP and robotics. NLP will help robots understand and follow natural language instructions, making human-robot collaboration intuitive. Combined with vision and action models, robots will execute tasks in factories, homes, and hospitals. Natural language interfaces will be the key to human-friendly robotics. Future of NLP in accessibility. NLP will improve accessibility by enabling speech-to-text, text-to-speech, real-time translation, and AI-driven tools for people with disabilities. For example, visually impaired users could use NLP-powered assistants to interpret documents or scenes. Accessibility will be one of NLP's most impactful contributions. How NLP will shape human-AI interaction. NLP will make human-AI interaction seamless, natural, and context-aware. Instead of clicking menus or coding, people will simply talk or write to machines. With multimodal integration, NLP will enable collaborative AI partners that understand intent, context, and emotion, transforming how we work, learn, and communicate. You've now mastered 200 NLP interview questions and answers, spanning fundamentals, deep learning, real-world applications, and the future of language AI. But here's the truth. Interviews aren't just about knowing definitions. They're about explaining concepts with clarity, connecting them to real-world problems, and showing that you can think like an NLP engineer. Keep practicing these answers. Speak them out loud. Link every concept to an example from industry. That's how you transform knowledge into confidence. As NLP continues to shape the future of healthcare, finance, accessibility, and human AI interaction, you are preparing not just for an interview, but for a career at the heart of the AI revolution. If this helped you, like, share, and subscribe. And join me in the next series, where we'll tackle reinforcement learning, recommendation systems, and generative AI interviews. The journey doesn't end here. It's only the beginning.